Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
1840 Augustin Louis Cauchy exercises d'analyse et de physique mathématique. The exercises d'analyse et de physique mathématique, published by Augustin Louis Cauchy in 1840, represents significant contribution to the evolving landscape of mathematical analysis and its applications to physical problems. This essay undertakes a rigorous, section-by-section examination of Cauchy's work, focusing specifically on the validity, internal consistency, and enduring influence of its central claims. My intention is to provide a detailed critical evaluation of Cauchy's arguments, methodology, and conclusions as they are presented within the text itself. The broader intellectual context, including prior works and contemporary debates, shall be considered only to the degree that it elucidates the internal coherence and significance of Cauchy's assertions. Section 1 Introduction on the nature of mathematical analysis and its purpose. Cauchy, in his introductory remarks, establishes a foundation for his approach. He defines the essence of mathematical analysis as a science that endeavors to deduce the properties of functions from their initial definitions. The intent is to provide precise, rigorous methods accessible through logical deduction, beginning with fundamental concepts and progressively unfolding into more complicated areas of mathematics. The purpose is not merely theoretical. Cauchy emphasizes the necessity of providing tools for the investigation of physical phenomena. He describes methods for tackling problems encountered in mechanics, optics, and the study of curves, positioning mathematics as a vital instrument in scientific inquiry. The emphasis is decidedly on clarity, rigor, and the pursuit of truth. The work, in this sense, promises to demonstrate the intimate connection between mathematical abstraction and physical reality. Section 2 on the concept of limits and its application to calculus. Cauchy's articulation of the notion of limits forms one of the most foundational aspects of his work. He elaborates on the definition of a convergent series, presenting a condition for its convergence. The sum of any number of terms after a certain point should be arbitrarily small. He then uses this definition to rigorously define the derivative and the integral. This approach departed from the more intuitive, often less precise methods employed previously. Cauchy's commitment to this approach is evident in his repeated insistence on the importance of establishing clear criteria for convergence, thereby removing ambiguity and ensuring the soundness of mathematical results. The consequences of this work are significant. It provides a solid basis for the development of calculus as a precisely justifiable and universally applicable discipline, replacing the reliance on infinitesimals with a more robust notion of limits. Section 3 concerning the continuity of functions and its implications. Cauchy meticulously examines the concept of function continuity. He provides a precise definition. A function remains continuous in a particular interval if and only if infinitesimal changes in the independent variable result in infinitesimal changes in the dependent variable. This emphasis on the relation between the independent and dependent variables establishes a critical framework for understanding function behavior. Cauchy applies this concept to various situations, demonstrating the importance of continuity in ensuring the validity of certain mathematical operations. He also clarifies the significance of discontinuities, demonstrating how discontinuities can signal important changes in the behavior of a function or a physical system. It should be noted that there are subtle differences between Cauchy's idea and the more general notion. By focusing on continuous functions, Cauchy provides the necessary tools for accurate modeling, in contrast to situations where continuity is missing. This section demonstrates Cauchy's mastery of function characteristics and their role in analysis. Section 4 on the theory of series and their convergence. Cauchy dedicates a significant portion of his work to the detailed study of series, particularly their convergence and divergence. He elaborates on various convergence tests, including the ratio test and the root test, which provide methods for determining whether an infinite series converges to a finite value. Cauchy introduces new criteria, notably for series, which are then employed in subsequent solutions. The importance of these tests lies in their capacity to provide a rigorous foundation for working with infinite series, preventing the careless use of divergent series that had previously led to inaccurate results. The ratio test, for example, is derived and elucidated, showcasing its ability to determine the convergence of a series by comparing the ratio of consecutive terms. He also investigates the conditions under which series can be manipulated through addition, subtraction, multiplication, and differentiation. These manipulations, if done carelessly, can lead to false conclusions. Cauchy's work provides the tools to approach such operations with confidence. Section 5. Applications of analysis to the study of curves and surfaces. Cauchy extends his analytical methods to the study of geometric forms. He employs the tools of calculus, including differentiation, to analyze the properties of curves, such as their tangents, normals, and curvatures. He also explores the surface, using similar techniques to investigate the gradient and the curvature of surfaces in three-dimensional space. The intent is to demonstrate the power of analytical methods of geometry, highlighting the capacity of calculus to reveal intricate features. The work is detailed in the use of tangent lines, and by extension, the determination of the slope of a curve at a specific point. It emphasizes his ability to go from theoretical tools to geometric applications. Section 6 on the application of analysis to problems in mechanics. This section explores the application of analytical techniques to problems in mechanics. Cauchy delves into the study of motion, emphasizing the importance of differential equations to model real-world systems. The main focus is his mathematical method of analysis. He tackles the study of oscillatory motion, which is represented mathematically by differential equations. He analyzes the equations that describe these periodic phenomena, providing insights into the behavior of systems that experience oscillations. His methodology emphasizes the importance of setting up an equation, then solving the mathematical equation. The methods, though technical in their nature, reveal the elegance and descriptive power. This marks an important step in the scientific understanding of the physical world. Section 7. Investigation of the wave equation and its solutions. Cauchy extends his analysis to address one of the most relevant areas of physics, the study of wave propagation. He examines the wave equation, a partial differential equation. His objective is to determine the solutions, which represent the behavior of waves through space and time. Cauchy explores linear and nonlinear situations, including various boundary conditions. He focuses on methods to solve the wave equation under various conditions, providing insights into the behavior of waves, including the propagation of light and sound. The investigation is significant, as his study lays the groundwork for later developments. He then proceeds to work out those solutions. Using different methods, careful attention is given to the discussion of the physical interpretation. Section 8. The study of heat conduction and its mathematical representation. Cauchy investigates the phenomenon of heat conduction, describing the movement of heat through materials as a function of time and space. He formulates the heat equation, a partial differential equation, to model this behavior. Cauchy tackles the equation by looking for solutions. The goal is to describe the flow of heat in various scenarios, including the distribution of heat within solid objects. Cauchy analyzes the equation, exploring how it describes the variations in temperature. His work provides a clear and effective method to approach the problems involved with heat conduction. Section 9. The investigation of the stability of equilibrium points. This section extends the scope to the study of the stability of equilibrium points in physical systems. Cauchy's focus is how a system returns to its original, static position. It's particularly relevant to understanding oscillatory phenomena. His work involves the use of differential equations to model the system. Cauchy establishes criteria to determine whether a system remains stable or diverges from its equilibrium point. The investigation is critical for understanding the behavior of systems under various conditions. The focus is a detailed analysis of stability. Section 10. Method of successive approximations as a solver of equations. Cauchy presents the method of successive approximations to solve an equation. This technique starts with an initial guess and refines it iteratively. For this reason, this method is a significant departure from earlier ones. Cauchy discusses the conditions under which the series converges to a correct solution. Cauchy sets the theoretical stage for numerical solutions. The technique is widely applicable in numerous fields because it can be used to determine accurate solutions. The method of successive approximations provides an invaluable tool. Section 11. Additional topics and further applications. This final portion of the work encompasses a range of additional topics and further applications. Cauchy elaborates on specific problems in physics and mechanics. He applies analytical techniques to diverse situations. He discusses mathematical tools and presents solutions to problems. The section displays the flexibility and expansiveness of mathematical analysis. Cauchy demonstrates the wide applicability of the methods he has introduced throughout the exercises. Conclusion. Cauchy's exercises d'analyse et de physique mathématique represents a pivotal contribution to the advancement of mathematics and its application to the physical sciences. His meticulous formulation of limits, continuity, and convergence provides a rigorous foundation for calculus. The detailed exploration of series, the study of curves and surfaces, the analysis of mechanical systems, the investigation of waves and heat conduction, the exploration of the stability of equilibrium points are all testaments to his intellectual. The value of Cauchy's work does not reside simply in its technical achievements. The commitment to rigor and clarity is its enduring legacy. The explicit and exhaustive definitions, the clear statements of theorems, and the methodical proofs create a standard. Cauchy's choice of language enhances clarity and demonstrability. His focus on the intimate connection between mathematical abstraction and the physical world is also very prominent. The exercises demonstrate the value of mathematics in solving complex problems. Cauchy's mathematical insights are essential to the future progress of mathematics and fields that use it. The emphasis on rigorous analysis provided the foundation for subsequent generations of mathematicians. The work remains a testament to the power of mathematical reasoning and its profound impact on our understanding of the universe. With his clarity and rigor, Cauchy firmly established many of the foundations of modern mathematical analysis that are still in use today. His influence cannot be disregarded.
We really appreciate you tuning in to this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.